going to show you how to graph inequalities on a number line. So inequalities, when we say inequalities, what we're talking about is when we have an equation and it ends up something, instead of where we in the past we might have x equals 7 or y equals 3, this is when we're actually not going to have an equal sign, but we're going to have either a greater than or less than sign, such as x is less than 7 or y is greater than 3. The way we show this on a number line, let's take a look at the x is less than 7. Draw a quick number line, and you don't have to do all the way from 0 in the middle. Go closest to the number 7, put that in. It's going to be an open circle. You don't fill in that dot. It's an open circle. Take a look at this inequality, which says x is less than 7. That means x, whatever this number is, it can be anything below 7. So it could be a 6.5, it could be a 6, a 5, and so on. And this means x is any number less than 7. Looking at the line here and such like that, put the number 3 here, 4, 2, the open circle around the 3, and this time because y is greater than 3, that means that any number greater than 3 will work. So that means y is any number. Now I'll do the very similar problem, but instead of writing x is greater than 7, I'm going to write x is greater than or equal to. This bar down here means it can also be equal to 7. It's kind of like the equal sign has those two bars. Well, when we do this greater than or equal to, we use one of the bars from the equal sign, and then we use this greater than sign. And I'll put this on my number line, and I'll put a 7 there. This time, instead of having an open circle like I did before, because I am including 7, because 7 can be something that x can be, I will put a solid dot there. And still, again, because x is any number greater than 7 also, besides being, it could be equal to, I will still shade this direction towards all the numbers greater than 7. Back to the y equals 1, where it was a y is less than 3. If I add in y is less than or equal to 3, the same thing's going to happen. I'm going to put my number 3 right there. I'm going to fill in the whole circle there, and then everything below 3. We can solve for equations that are inequalities. Let's take something such as if we had before, let's say an equation said that x plus 7 is equal to 8. Of course, then in the past we would solve that. We would say, when you solve this, you would subtract a 7 on both sides of the equal sign, and that would cancel out, and we get x is equal to 1. We can do the same type of thing with inequalities. Instead of being x plus 7 equals 8, let's try x plus 7 is greater than 8. You're still going to solve it the same way that you would with the regular equal sign. I'll subtract a 7 for both sides of the greater than sign. This will go away, and now I have x greater than 1. And then again, we'll graph this. We'll put a 1 here, and because it says greater than, if it's greater than, we're not going to fill in this number right there, but any number greater than that. In this case, when we have equations, remember we had an equation such as 3y equals negative 12. We would divide both sides of the equation by 3 to get y equals negative 4. In this situation, when we have 3y is less than negative 12, I'm still going to divide both sides by 3. These will cancel, the 3 and the 3, and I will have y is less than negative 12 divided by 3 is negative 4. Graphing that, putting a negative 4 here. Because it says that it is less than, it doesn't say less than or equal to, do your open circle, and less than means that we go everything below negative 4. Now I'm going to combine the methods of adding or subtracting to both sides of the equal sign and then dividing. If you were to solve this, if this were a equation with an equal sign, how would we have solved that? You would have added 5 and added 5 to both sides. Well, we can do that here. I'll add a 5 to this side of the less than equal sign, and then I will add a 5 over here. This will get me, I'm only going to be left on this side with a 3y because these cancel. And then I have less than or equal to 12. Dividing both sides by 3 as I would here. If I had 3y equals 12, I would divide both sides by 3 and I would get y equals 4. Here I'm dividing both sides by 3 and we get y is less than or equal to 4. Putting that on a number line, find 4, I'll put a 4 there. Because it says y can be equal to 4, I'm going to fill that in with a solid dot, and then y is any number less than or equal to 4. I will shade the numbers lower than 4. Sometimes you will be given the graph of the inequality and be asked to write the equation from it. We look at this inequality here graphed and notice that there's a solid circle where 6 is. Therefore, we can use any variable. Often we'll use x. I will write x is, and I know I'm going to be using a positive 6. Because it's a solid circle, not a wide open circle, I know that it could be equal to 6. And then the shaded part is everything above 6. That means that we are going to write x can be any number greater than or equal to 6. Looking at this one, we'll start with x. We have the number 1 is circled, but it is not filled in. So we're not going to use that little equal sign. We're not going to use that. We're going to just say that the x is, notice how we're using the 1 right here, but it's shaded below the 1. Any number below 1. So x is any number less than 1.